So today we are going to look at lesson 13-2, part 1. We're going to find side lengths using trig. We're going to find missing angle measures using trig as well. So those are the two things we're going to concentrate on. Number 1, make sure you check your calculator's mode and make sure that it's in degrees. Even if it's your own calculator, somehow it can get out of the wrong mode and get into radians. And you want to make sure it's in degrees. So double check that on the TI. The mode button is to the right of the second function key. So just make sure that degrees is highlighted. All right, so let's review a couple of things from geometry regarding trig. So first and foremost, we are going to be creating equations that are in one of the following forms. So you're either going to choose sine. I'm trying to draw in here without putting my wrist on the paper. It's a little difficult today. So you're going to choose sine, cosine, or tangent of some degree is going to equal some ratio. And you might have heard your teachers mentioned SOHCAHTOA. The only issue with SOHCAHTOA is knowing how to spell it. So most kids can say, oh, it's SOHCAHTOA, but then they can't spell it correctly. So here's how you spell SOHCAHTOA. Some old hippie caught another hippie tripping on acid. Some old hippie caught another hippie tripping on acid. So what that means is sine opposite hypotenuse, cosine adjacent hypotenuse, tangent opposite adjacent. So we spent, well, let's go ahead and just draw a regular right triangle. And let's say that this is theta. So we talked about theta in the last lesson. And if theta is our angle of reference, so I'm going to circle that. If that's our angle of reference, remember 2 theta, as we discussed, this side would be the side, whoops, that is not what I want. So this side opposite theta, this leg is going to be side opposite. And then this side is really the most important side. It's across from the right angle. That's your hypotenuse. So the hypotenuse can never be the side adjacent. So that leaves this side, which is touching our angle. It's our leg that is adjacent. So that's where the H, the O, and the A come from in SOHCAHTOA. All right, so let's look at some problems. And we're going to start off with our angle of reference. So if my angle of reference is 64 degrees, then I'm going to label my sides. So the side opposite 64 is the X, and then the 25 is across from the 90 degrees, so it is the hypotenuse. So up in the upper right here, I'm going to write OH, opposite hypotenuse. Out of SOHCAHTOA, the only one that has an O and an H in it is SO, or sine. So we are going to go through and write out our equation. So since we're using sine, we have sine of some degrees equals some ratio. So because it's sine, it's some old hippie. So I know my degrees is 64 degrees. So I'm going to put my degrees in here as 64. And then I know that my opposite is X and my hypotenuse is 25. So I'm going to put my X here and my 25 here. Then all we have to do is use our algebra to solve. Since I have a fraction equaling a non-fraction, I am going to turn this non-fraction into a fraction, and then I am going to cross multiply and solve. So 1 times x is x equals, and then I have 25 times the sine of 64. 25 times the sine of 64 degrees. And so then this is the part that goes in your TI calculator. So you're going to write it exactly as you see it, 25 sine of 64, and that's why it's important to make sure that your mode is in degrees, because we're putting degrees into the calculator. And then we are going to round to the nearest tenth, as the directions say. So then x is approximately equal to, and you need to practice this on your calculator so that you know how to substitute it in. Excuse me. All right, so then that's approximately 22.5 units, whatever that might be. All right, so then let's look at number 2. Number 2, we're going to go, and all of these are going to be done identically. So if this is my angle of reference, I am then going to identify my side opposite, adjacent, or hypotenuse. Well, since this is my hypotenuse, these have to be the side opposites or adjacents. So the side opposite is x, and the side adjacent is 12. So here's my opposite, and here's my adjacent. So then I'm going to put over here in the upper right an O and an A, and the only part of SOHCAHTOA that has an O and an A would be TOA. So I'm going to put a T here, and that just means tangent. So I'm choosing tangent of some degrees equals some ratio. And so because we are tripping on acid, that's how I know how to set up my ratios. So my angle of reference is 47 degrees. So 47 goes here. And then my opposite we labeled as x, and my adjacent as 12. So then I'm going to create a fraction over here, and then I am going to cross multiply. So 1 times x is x, and then 12 times tangent of 47 degrees is 12 tangent 47 degrees. So this is what goes into your calculator, that part. So you do that, and then round to the nearest tenth. So you should get approximately 12.9. And I might point out that you are welcome to pause the video at any time if you need to stop to write something, because I'm going too fast. The joys of a video. All right, so then example 3. I want you to do this one on your own, so pause the video. Try to figure out whether it's sine, cosine, or tangent. Set up your equation, cross multiply, and solve, and put it in your calculator. Then restart the video and check your work. All right, so my angle of reference is 18 degrees, and according to my angle of reference, this is my hypotenuse, and this is my side adjacent. So over here I'm going to put an A and an H, and out of SOHCAHTOA, only Ka has an A and an H. So that means I am choosing cosine of some degrees equals some ratio. So because it's cosine, we have caught another hippie. All right, so my degrees is the 18 degrees, and then my adjacent is x, and my hypotenuse is 34. We're going to create our fraction and cross multiply. So I get x equals 34 cosine of 18 degrees. So in your calculator is going to go this part, and you should have ended up with x being approximately equal to 32.3. All right, so hopefully you did well at that. So then with number 4, something difference starts to happen. So let's look at number 4, and then you can try 5 and 6 on your own. So sometimes your variable does not end up in the numerator of the fraction, it ends up in the denominator, and that creates just 2 steps instead of a 1 step. So in this case, your angle of reference is the 35. And according to the 35, 9 would be the side opposite, and x would be the side adjacent because it is not the hypotenuse. So then I'm going to put an OA over here. Out of SOHCAHTOA, only TOA has an OA, so we are going to choose tangent of some degrees equals some ratio. So again, you can see I'm going about it exactly the same way. So because we're using tangent, we are tripping on acid. And my degree is 35. My opposite is 9. And my adjacent is x. So as you can see, we have x in the denominator this time. So when we go ahead and create that fraction, as we have done all 3 times in the previous 3 examples, when we cross multiply, however, this time I get x times the tangent of 35. So I get x tangent of 35 degrees equals, and then 1 times 9 is just 9. So then you have to undo this in order to solve for x. Since x is being multiplied to the tangent of 35, the only way to undo that would be to divide both sides by the tangent of 35 degrees. What you do to one side, you must do to the other side. So the tangent of 35s cancel, and then what you are putting into your calculator is this. All right, so that goes into your TI, so please try that. So pause the video and try putting that into your calculator. If you take 9 and divide it by the tangent of 35, you should get approximately 12.9. If you don't, ask me for help and I can figure out what you're doing wrong. All right, so I'd like to have you try, so pause the video, I want you to try 5 and 6 on your own, and then restart the video and check your work. All right, so this is your angle of reference, and that x is the side opposite of the 90 degrees, so this is your hypotenuse. 27 is the side opposite. So you have an O and an H. Out of SOHCAHTOA, that would be so. So we are choosing sine of some degrees equals a ratio. So some old hippie. So my degree is 63. My opposite is 27, and my hypotenuse is x. So when I create that fraction and cross multiply, I get x times the sine of 63 degrees is equal to 27. To solve for x, you have to undo multiplying. So we are dividing by the sine of 63. The sines of 63 cancel, and then this is what goes into your TI calculator, and then x is approximately equal to 30.3. All right, then do number 6, stop the video, do your work, and then check it. All right, so our angle of reference is the 30, right? And so x is your hypotenuse, and 18 is adjacent. So we have AH. Out of SOHCAHTOA, Ka has an A and an H. So we are choosing cosine of some degrees equals some ratio. So we have caught another hippie. So our angle is 30, our adjacent is 18, and the hypotenuse is x. So these are the harder of the two types of equations. You either have you can have your variable here, here, or here. We're going to talk about the variable here in a minute, but out of your variable being in either the numerator or the denominator, clearly the denominator is a little bit more difficult. So if you can just get the process down, you should be good to go. All right, so cross multiplying, we get x times the cosine of 30 degrees equals 1 times 18 is 18. Undo multiplication by dividing by cosine of 30. And then we cancel the cosine of 30. And in your calculator, you should be putting 18 divided by the cosine of 30. And we get x approximately equaling 20.8. So that's all there is to finding side lengths using trig functions. So then let's talk about inverse functions. So let me make this just a little bit smaller for a minute so I can get all of this in the picture. So if you know sine, cosine, or tangent ratios, and that was some old hippie caught another hippie tripping on acid, and we worked on that in the last lesson, you can use the inverse of the ratio. And this is what the inverse of sine, cosine, and tangent means. And an inverse really is just a reciprocal. And we can use that to find the measure of the angle. So and you'll notice that they have sine of theta, which is some degrees, equals x. Well, I'm going to change all of these equals x to their ratios. So some old hippie, so it's O over H, caught another hippie, so it's A over H, tripping on acid. So I specifically want you to change those x's into those ratios. So if I know both of these numbers in this fraction and I don't know the degree, same thing here, if I don't know the degree but I know these, don't know the degree but I know these, then we can use this inverse sine, inverse cosine, and inverse tangent. It is not sine to the -1 or cosine to the -1 or tangent to the -1. It is read the inverse sine, inverse cosine, inverse tangent. So please say them correctly. Otherwise it will drive me insane. All right, so if you want to find theta, which is any degree measure, it is going to equal, and this is how you'll write it in your calculator, you'll do the inverse sine, and to get to the inverse sine, you use the second function and just hit the sine key. So you'll notice that this inverse sine is above the sine key. Same thing with cosine and with tangent. And then immediately parentheses are going to pop up, and in the parentheses you're going to put that ratio of O over H. So for cosine, same thing. If you don't know theta, you're going to use the inverse cosine, and these parentheses will pop up. Well, the starting parentheses will pop up. You have to close it. And then you'll put in the ratio of A over H. And finally for tangent, if you don't know theta, you'll use the inverse tangent, and those parentheses will pop up, and you'll put in the ratio OA. So how does this look like in some problems? So we've got, I think, 4 problems to do. So I'm going to make these bigger. All right, so we are going to round these to the nearest tenth as well. So we're going to go through exactly that same process. This is my angle of reference. Even though it's theta, it's still my angle of reference. We are still going to label the sides as opposite, adjacent, or hypotenuse. So I don't know my hypotenuse, but this 8 is my opposite, and the 14 is my adjacent. So again, the process is still the same. I'm going to put OA over here in the corner, and out of SOHCAHTOA, the only one that has just an O and an A is TOA. So we are going to choose tangent of some degrees equals some ratio. And so as you can see, nothing has changed. I circled my angle of reference. I labeled my sides. I decided whether I had SO, CA, or TOA, which then told me whether I was going to choose sine, cosine, or tangent of degrees equals this ratio. So nothing has changed from what we did in questions 1 through 6. And I still am going to do the same thing, tripping on acid. I'm going to fill in these 3 blanks here with what I know. So my degree is actually theta, and then my ratio opposite is going to be 8, and adjacent is going to be 14. So here you can see that we don't have a variable in the fraction. So anytime your variable or your unknown is here, which typically is going to be shown by a Greek letter, quite often it's going to be theta. They use a bunch of others, but that's one of their more popular ones. It can even be x. It could be just x degrees here. You'll often see that as well. Anytime your unknown is here in the degree blank, you have to use the inverse function. So I'm going to use inverse tangent. So immediately I write theta equals, just as we wrote above, inverse tangent of, and then my ratio 8 over 14 is going to go in here. So this 8 over 14, that's what went in here. And then this is what you're going to put into your calculator. This whole part goes in the TI. That's the part that you look for. And again, you still want your mode in degrees because you want your angle to turn out to be in degrees. So try it on your calculator. And if you round to the nearest tenth, theta should be approximately equal to 29.7, and then you have to attach degrees because that is its unit of measure. So don't forget to attach that degrees or you'll get marked wrong. All right, so I'm going to do one more of these with you and then have you do 2 on your own. So once again, same process as before. This is our angle of reference. And let's label our sides. I do have a side across in the right angle, which is the 40, so that is my hypotenuse. That makes this other leg here touching my angle the adjacent leg. So I have an A and an H. In SOHCAHTOA, only Ka has an A and an H, so I am choosing cosine of some degrees equals some ratio. So I have caught another hippie. My angle is theta. My adjacent is 38. And my hypotenuse is 40. So since we don't know theta, we are going to use the inverse cosine in order to find theta. So theta is equal to the inverse cosine of, and then we're going to put our ratio in here, the 38 over 40. So this is the part that goes into your TI. So please practice that. So pause the video. And then theta is approximately equal to 18.2 degrees. So not bad. We have 2 more to do on the back, and then we will be done with today's lesson. Okay, so I would like you to pause the video, and I want you to do 9 and 10 on your own and see if you understand that process, and then you will be good to go on your homework. So pause the video and then come check your work. All right, so here's your angle of reference. You're going to label your sides. This is your hypotenuse. This is your side opposites. So if I have OH out of SOHCAHTOA, that would be SO, which means I am choosing sine of some degrees equals some ratio. And so I have some old hippie. So my degree is theta, and my opposite, my old, is 17, and my hypotenuse is 22. Since I don't know theta, I am going to use the inverse sign, and then I'm going to put my ratio of 17 over 22 in there. This is what you should have put into your calculator. And finally, the moment you've been waiting for. Theta is approximately equal to, get my numbers here, 50.6 degrees. Don't forget your degrees. All right, if you haven't done number 10 yet, pause the video and do number 10. If you have, on we go. All right, so my angle of reference is right here. My hypotenuse is the 48. That means 11 is adjacent. So I have an A and an H. So out of SOHCAHTOA, Ka is the only one with an A and an H. So I am choosing cosine of some degrees equals some ratio. So we have caught another hippie. And my degree is theta. Adjacent is 11, and the hypotenuse is 48. So because I do not know theta, we are going to use the inverse function. So theta is equal to the inverse cosine of, and I am putting 11 48ths in here, popping that into my calculator. This is the part that goes in the calculator. You should come out with theta being approximately equal to 76.8 degrees. And that's it. So good work today. Now finish your homework and let me know if you have any questions.